In this video, I'm going to start my chapter 6, section 5 for my daily kids. And in this section, what we're going to do is investigate whether or not a point is a solution to an inequality. And I'm going to show you first just kind of a graph of an inequality. So just kind of talk about inequalities first. Instead of having an equal sign, your inequality equation is going to have, if you can see here, I'm going to try to highlight this function right here. You're not going to have an equal sign in an inequality. You're going to have a symbol that's greater than, less than, greater than or equal to, less than or equal to, and what you get is a graph of a line, but you also have what's called shading, and shading is going to indicate which part of the graph hold the solutions for, in this case, less than. So notice how underneath of the line is shaded. All of these points underneath of your line would indicate solutions to this inequality. And so what I want to do is just kind of first talk about visually the picture and then talk about points that would be solutions, and then we'll actually start graphing on the next page over here. So we'll talk about how to get that graph. So first what I want to do is just kind of go through some vocab, and then we'll talk about solutions, your points, whether they're solutions or not. Now it says the graph of the solutions to a single inequality is called I want you to fill this out here, half plane. Because it includes all the points on the coordinate plane on one side of your boundary line. So I want to kind of review here. If you said x was greater than 3 and you drew yourself a number line and you put the number 3 on here, on a number line, you'd shade half of your number line. You'd shade part of it. You know, you'd circle your 3 and you do some shading. So if I wanted greater than, I'd shade to the right. Well, we're going to do the same thing, but with a linear equation on a plane. So not just a number line like one dimension. Now we have 2 dimensions. So we get what's called a half plane. Now, checking solutions of a linear inequality, we're going to do it graphically and then algebraically. This is how it works. Example 1. Given below is the graph of this inequality. It's the line 2/3 x minus 1. And notice how my equal to sign is a less than sign. So that means instead of drawing your line, you're going to have not only the line, but you're going to have some shading. So less than, we would shade underneath of the graph where the points are smaller, and I'll show you how to get this graph in the next couple videos. But what we're going to do is check to see whether each point is a part of our solution, and this is what we do first. So I'm going to plot each of these points on our grid, and then we're going to talk about whether it is in the solution area or not. So this point 3, -2, we're going to go from the origin, right 3 down 2. Is this point in the shaded region? And if it is, your answer will be yes, this is a solution. So since that's in the shaded part, you're good to go. Now the next point is 3 but +2. So we're still going to go over 3, but this time up 2. This is not in the shaded section, so my answer would be no, 3, 2 is not a solution. And then likewise, we're going to go -1, 3, or left 1 and up 3. This is definitely no, not in that shaded region. And then for part 4 here, the point -2, -3, I'm going to go from the origin, left 2 and down 3. Is this point in your shaded region? Yes, it is. So my answer would be yes. Now, what would you do to check your function, but if you didn't have the graph? How would you check it algebraically? And I want to show you how you do that next. So in this example, we're going to plug in a point, and here in this example it says check if your ordered pair is a solution to your inequality, and what you're going to do is use substitution. And after we substitute in our x value and our y value, what we want to do is look and see if the inequality is true. And if it is true, then that value, the point that you substituted in, would be a solution if it is true. So what I'm going to do first is copy down that inequality here, and I'm going to do that for each one. So I have 2x minus 3y is greater than or equal to -2. So what I'm going to do is substitute in for my x the number 0, and substitute in where you see the y also the number 0, since it's 0, 0. So is 2 times 0 minus 3 times 0 greater than or equal to -2? Well, let's do our math. 2 times 0 is 0. 3 times 0 is 0. And after I subtract those, 0 minus 0, it is 0. So is 0 greater than or equal to -2? That is true. So that means that 0, 0 is a solution. So we'd say yes. Yes, it is. Now we're going to do the same thing, but we're going to switch our points. So instead of using 0, 0, I'm going to use 0, 1. So again, I'm just going to copy down that original function. I'm going to make sure I copy it down correctly. So I'll take an extra second and double check. Now I'm going to plug in 0 for my x, because this point is x comma y. And I'm going to plug in where I see the y, the number 1. And I'm going to do some algebra and check to see if we get a true statement. Well, 2 times 0 is 0. 3 times 1 is 3. And now I'm going to do my subtract. So PEMDAS, we're going to multiply before we subtract. 0 minus 3 here is going to be negative 3. Is negative 3 greater than or equal to negative 2? False. So 0, 1 is not a solution. And then here is our last point to check. 2x minus 3y is greater than or equal to negative 2. So for my x, I'm going to put the number 2. For my y, I'm going to put the number 1. And I'm going to see if I get a true statement. 2 times 2 is 4. 3 times 1 is 3. Is 4 minus 3 or the number 1, is that greater than or equal to negative 2? Yes, true. So that means the point 2, 1 is a solution. And that's how you check for your points.